Hello, Matt here from ChemistryStudent.com. In this video, we're going to look at the nitration of phenol. We're going to talk about what the nitration of phenol actually means and compare the nitration of phenol with the nitration of benzene. The structure and other reactions of phenol are outlined in separate videos. Check the links in the description below. Before we talk in detail about the nitration of phenol, there are a few essential ideas you need to be comfortable with. Phenol is a cyclic compound with the formula C6H5OH. It is essentially a benzene ring with an OH group attached. Benzene is a cyclic hydrocarbon with a delocalized electron ring. There is a pi bonding system where delocalized electrons exist in rings above and below the plane of the carbon ring. This gives benzene its relative stability and is also why benzene reacts with electrophiles. Electrophiles are electron pair acceptors. They are usually positively charged and are attracted to areas of high electron density. A nitro group is NO2, and the electrophile responsible for adding the NO2 group to benzene and phenol is a nitronium ion, NO2+, formed from nitric acid. Recap done, let's go. Phenol can react directly with dilute nitric acid to form a mixture of 2-nitrophenol and 4-nitrophenol. This is an example of a nitration reaction. If concentrated nitric acid is used, the product formed is 2,4,6-trinitrophenol, as the phenol undergoes multiple substitutions. Unlike in the nitration of benzene, no catalyst is needed. The ring of delocalized electrons in the benzene ring mean phenol is vulnerable to electrophilic attack and will react with electrophiles. The reason phenol is able to react directly with nitric acid and benzene is unable to is because of the hydroxy, or the OH group, bonded to the benzene ring in its structure. The activating nature of the OH group effectively adds electron density to the ring and makes it more reactive and likely to undergo electrophilic substitution. This activating nature of the OH group in phenol has been covered in more detail in a different video called Phenol Structure and Properties. Check out the link in the description below if you're unsure about it. The formation of 2-nitrophenol and 4-nitrophenol comes from the directing effect of the OH group in phenol. In very simple terms, a lone pair of electrons from the oxygen gets fully donated into the pi bonding system, giving the oxygen atom a positive charge. There is now a negative charge from the lone pair of electrons that can be moved around the structure, and due to the bonding system in the benzene ring, this can end up at either carbon 2 or 4. Technically carbon 6 as well, but that would just be carbon 2 if only one substitution is occurring. The negatively charged carbon is always going to be the one most likely to react with an electrophile, and this is why substitution occurs at carbons 2 and 4. This has been outlined in a little more detail in the phenol section at ChemistryStudent.com. I wouldn't worry yourself with it too much though, just focus on the reaction overall and the product formed. Phenol is also able to undergo multiple substitution reactions with concentrated nitric acid and will end up forming the product 2,4,6-trinitrophenol. The 2,4,6 refer to the carbon atoms that the nitro group get bonded to. Carbon 1 in phenol is always considered to be the carbon that the O in the OH group is bonded to. Trinitrophenol just means that there are 3 nitro groups bonded to the phenol. So, to summarize, phenol is a cyclic compound with the formula C6H5OH. It is essentially a benzene ring with an OH group attached. Phenol is able to react directly with dilute nitric acid in a nitration reaction, unlike benzene that needs a catalyst. The OH group in phenol activates the benzene ring and makes it more likely to react with electrophiles than benzene. This happens as a lone pair of electrons on the oxygen atom gets spread or donated into the delocalized system in the benzene ring, increasing the electron density. 2 possible products are formed when phenol reacts with dilute nitric acid. When reacted with concentrated nitric acid, further substitutions occur and 2,4,6-trinitrophenol is formed. The OH group in phenol has a directing effect, 2,4,6 directing effect, meaning that as multiple substitutions of the nitro group occur, the final product is 2,4,6 trinitrophenol. I hope you found this video useful. Please check out other relevant videos in the links given in the description below, and visit chemistrystudent.com for free notes and revision materials.